All right, on the front board is your warm-up. Does everybody see it? So here's what you need to know about me. When I was in college, I was in a professional women's music fraternity. I know some of you are looking at me like I'm weird because I was in a fraternity, and everybody knows fraternities are for boys and sororities are for girls. But our music fraternity was formed before there were such things as fraternities. It was formed in 1908. Okay? So this was the name of our fraternity. We haven't gotten to this one, so I'll tell you it's a sigma. What's this one? Alpha Iota. Because this letter in Latin is not I. Okay? It's E. Iota. Okay? Sigma, alpha, iota. So I tell you that, sir, for two reasons. First of all, because it goes along with our warm-up this morning. And second of all, because now you know that I'm also an amazing singer. Okay? You know I play band. You know I can play like 15 instruments in band. Or at least 2. Okay? But now you know I'm a good singer, too. Okay? Now, what's interesting, well, it was interesting to me. I don't care if it's interesting to you. They came and asked us to join, right? We didn't, go searching out to join. They came and asked us to join because they didn't have a lot of band people in it. In fact, that year they had no band people in it. So they came and asked my friend Jennifer and I if we would join their fraternity. And we did, and we had fun. It was a service organization, so we sang a lot, but we also helped out when there was recitals. We served the reception afterwards and things like that. It was a lot of fun. I met some great people in there. Okay? But it also goes along with our lesson for today. Okay? So the first thing I want you to do, because you already have your notes out, ready to take notes, is I would like you to clear your throat. Like, okay? Everyone's going to clear their throat. Okay? Because, yes, we are singing together as a group. Okay? And this is what we're going to sing. Let me teach it to you. You be quiet while I sing. It's my moment. This is how it goes. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now together. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And now a half step up. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And one more time, another half step up. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What's it for? It doesn't do us any good to know an awesome, awesome song unless we know what it's for. How does it start? X equals. What do we normally do when we get an answer that's x equals? We are solving, okay? We're solving a quadratic equation or a quadratic function. So here's the deal. I've already taught you that if you have a quadratic, you can graph at it. Graph at it? I don't know what that means. Graph it. What are you looking for if you're graphing? Where it crosses the x-axis. That's exactly right, okay? Where it crosses the x-axis. But what if it doesn't cross at nice, pretty spots? Okay, so then I said, well, let's solve using square roots, right? But if it wasn't a nice, pretty square root, so then we talked about factoring. And then what if it wasn't nice factoring? So then I showed you completing the square. But if wasn't that really nice and neat? Guess what you can use? Quadratic formula. Works every time. So why in the world then would I teach you the other 4 ways if you know the quadratic formula works every time? Seems a bit ridiculous, doesn't it? Sometimes what? Sometimes this is not the easiest way. Right? If you have x squared minus 9 equals 0, can't you just add 9 to both sides and get x squared equals 9, square root both sides, you're done? Yes, super fast. If you have something that's super easily factorable, do we want to do this whole formula, or can we just factor it and get our solutions? If I graph it and look at the graph and it crosses really obviously at -2 and 5, do I want to do this formula? No. This works every time, but it is not always the easiest. So that's why I taught you those other ways. Okay? But now we need to work on this. Okay? So before we talk about actually using this, I want to talk about a little part of it. I want to talk about this part of it right here. That has a specific name. It's called the discriminant. Okay? It doesn't have anything to do with preferring to do problems without 2's in them, because that's discriminate, right? This is discriminant. Got it? Okay. Discriminant is just b squared minus 4ac. Notice I didn't circle the radical, did I? I only circled the b squared minus 4ac. And that number will tell us important stuff about the problem before we even get started actually trying to solve for x. Okay? First of all, there's 3 possibilities that this number is allowed to be. First of all, it's allowed to be positive, right? I can do all these calculations and I can get a positive number, correct? So what happens if I were to take the square root of a positive number? For instance, 36. What happens when I take the square root of 36? I get a positive and a negative 6. So I get 2 solutions. What kind of solutions are they? Thinking back to 2 days ago, they're real solutions, aren't they? So I get 2 real solutions. When my discriminant is positive, I get 2 real solutions. What happens when my discriminant is negative? For instance, negative 36. What do I get when I take the square root of negative 36? Positive or negative 6i, right? So I still got 2. I got a positive and a negative, but I got 2 what? Fake. Not fake. 2 imaginary solutions. So remember I told you there was 3 possibilities? Positive, negative, 0, right? 0. I could get a 0 for my discriminant. So if a positive number gives me 2 real solutions, a negative number for my discriminant gives me 2 imaginary solutions, I want you to think about this for just a second. If this number right here was 0, what would my answer be? Negative b over 2a. How many solutions is that? 1. 1. Is it ever going to be an I involved in that? No, because that's all 0, right? So 1 real solution. Now I want to be real clear. This also has a special name. Okay? It's called a double root. Because remember we have a quadratic, so we've got to have 2 solutions of some sort. Here we got 2 real, here we got 2 imaginary. I'm supposed to have 2. Well, I do get 1 real solution, but it's called a double root. Because if I were to factor it, what would it look like? It would look a lot like yesterday, wouldn't it? X plus 2 squared, like x plus 2 times x plus 2. So I'm still getting the 2 as my, or excuse me, the negative 2 as my answer. I just have it twice. Does that make sense why it's called a double root? It is one number, negative 2 and negative 2. That's really one number, but it's happening twice. Okay? So I do want to make this, especially for my visual learners, I want to make this pretty clear. Okay? Let me do with this. If this is my x and y axis, what does my graph look like? What does it look like when there's two real solutions? It's where it crosses the axis twice, right? So it can open up or down, but regardless, it's crossing the x-axis here and here, right? Everybody okay with that? So what does it look like if there's two imaginary solutions? Good guess, but no. Kind of. And probably yes, but I'm not worried about the first part, but the second part. It doesn't cross the x. Yeah, it doesn't cross the x. Okay? Wait, does it open up or down? It doesn't matter, but if it opens what? Where is it? If it opens up, it's above the axis, isn't it? If it opens down, where is it? Below the axis. Okay? So I'm going to draw mine like this. You okay with that? See how it does not cross the x-axis? So what does it look like for one real solution? What does that look like? How many times is it allowed to cross the axis? Once. Oh, exactly right. If my vertex is on the axis. Again, it can open up or down, right? But the vertex is the only point that touches the axis. 1 point. Yes, sir.
So on a negative one, it has two solutions?
Two imaginary solutions.
Oh, so they're not...
Like, it's the I, plus or minus 6I.
Where would it touch it twice?
Oh, it doesn't. It doesn't touch the axis at all. That's how we know that there's not any real solutions. Because real solutions are where it crosses the axis. Fundamental theorem of algebra says it has to have as many solutions as the highest exponent, which means there's got to be two. But when it doesn't cross the x-axis, that's where the imaginary solutions comes in.
So is that like where it's supposed to?
Not exactly. Yeah. It's okay. Any questions about this? So if we are going to use the discriminant or the actual quadratic formula, what do we have to know? What B is, A is, and C is. So let me give you, well, first of all, do you remember what a standard form of a quadratic looks like? So ax squared plus bx plus c equals what? Either 0 or y. If we're graphing it, it's going to equal y, isn't it? Okay? Otherwise, we've got to have it equal to 0. It can't equal like 7 or something like that. It's got to equal 0. Okay? So our a is always with our x squared. Our b is always with our x. And our c is always our constant. You okay with that? So what if my sample problem looked like this? 4x squared minus 5x minus 6 equals 0. Can we identify all of our variables? What's this? A. What's this? Notice what I underlined. Oh, the negative, right? I have to keep the sign with it too, don't I? And then what's C? Negative 6 is C. Okay? So for this problem, if I was just trying to find the discriminant, that's all I want to find right now. I want to tell myself, I want to give myself an idea of what kind of and how many solutions there are to this problem. The discriminant is only b squared minus 4ac. Well, b squared would be negative 5 squared. Minus 4 times negative 6. What is negative 5 squared? Positive 25. Please make sure you put your negative in parentheses if you're doing it in the calculator. If you don't, the calculator will tell you the wrong answer every time because it does order of operations. Okay, it'll square the 5 and then multiply by the negative if you don't put the parentheses there. So we got to be careful of that. Or you could just use your brain and square 5 and get 25. Or square negative 5 and get 25. Yes? So here we have a choice. Okay? Whatever way you choose, I want you to do it that way every time. Otherwise, you'll get messed up. Okay? Is this a minus sign or is that a negative sign? It doesn't matter, but we have to make a choice. So I've heard a lot of people say minus. So I'm going to pretend it's a minus. So I'm going to bring it down right there. So now I have 4 times negative 6. What is 4 times negative 6? Negative 96. Everybody okay with that? Hold on just a second. Does everybody see where I got 4 times negative 6? Yes. So I got negative 96. So this gives me 25 minus negative 96. Oh yeah, absolutely it would change to a plus sign. Good job. 121. What if we treated this as a negative 4? Well, then I'd have 25, and then I have negative 4 times negative 6. And what's that? That would be 96, right? A positive 96. Am I going to get the same answer? Yes, I am. You just have to be careful. You can't treat it like a negative sign and then write down a minus. You see what I'm saying? Just be careful is all I'm asking you to do. So now that you know that our discriminant equals 121, tell me about our solutions. That's exactly right. We have, because it's a positive number, we have 2 real solutions. It's as easy as that. I'm sorry I said easy. It's just like that. Fair enough? Now, some of you, I think, disagreed and said, yes, it is easy, but I don't want to be judgmental. Okay, I don't want it to sound like that. Some of you think it's easy, and that's fine. Some of you are still struggling. That's fine, too, as long as you keep working. I'm done with the problem. Because all I asked you was tell me about the discriminant. Tell me about the number of solutions. There's time to use this in just a second. But there's 2 types of problems on your homework. The first type says, use a discriminant to tell me how many and what types of solutions there are. If that's what we're doing, we're done. We got a positive number for our discriminant, and we said we have 2 real solutions. If all you're asked is how many and what type of solutions, we're done. Because we know how many and we know the type of solutions. I haven't gotten the 2 solutions yet. All I know is that there are 2 and that they are real. That's all the discriminant will tell us. Is everybody okay with that? Because it's positive. That's exactly right. We know it because this number right here that we got for our discriminant is a positive number. So that's the first type of problem on your homework tonight. You okay with that?
You just have to say if it's 2 real.
Or 2 imaginary or 1 real, which is a double root. That's all you have to say. The second type of problem on your homework says, what if we have actually 4x squared minus 5x minus 6 equals 0, and the directions? Solve. It's a quadratic. We're working on quadratic formula, so let's use the quadratic formula. Okay? What's A? What's B? And C? Right? So that's not really a big surprise because we had already done that on these notes right here, right? Okay? So let's use our quadratic formula to solve this. X equals negative B, but I only wrote a 5. Why is it not negative 5? Oh, so it's like the opposite too, right? So x equals negative B plus or minus the square root of B squared minus 4AC all over 2A. That's exactly right. In the formula, it's negative b. X equals negative b. But in this case, our b is already negative 5, so we have a negative 5. You okay with that? So now we just have to simplify. 5 plus or minus the square root of 121. I didn't just really do that in my head really fast. What did I do? Yeah, we already did that right here when we were talking about our discriminant, right? But are you okay if you had to do that with different numbers? Okay. All over 8. Now what? Am I done? Do I stop here? What you got? Do you know the square root of 121? 11. And if you didn't know that off the top of your head, you could use your calculadora, right? X equals 5 plus or minus 11 over 8. So now I'm done, right? Oh, okay, I can actually do the math, right? 5 plus 11. 16 divided by 8. 5 minus 11. Negative 6 divided by 8. We can keep it as a fraction, absolutely, but absolutely we do want to simplify it. So that's why we got negative 3/4. Very good. So we got to do some pretending real fast. Okay? Because like I said earlier to you, I'm only going to do this one example for you because I want you to have time to work on this in class. But I want to bring up some possibilities. Okay? What if I got to this point right here and I did all my work and it was right and I got 5 plus or minus the square root of 120 over 8? What if that's what it was? Do I know the square root of 120? No, but I know that 120 is divisible by 4. Why did I choose 4? I know the square root of 4, don't I? Okay, so this divides into 30, right? Do I know the square root of 30? Do I know anything that divides into 30 that I know the square root of? Not 4, not 9, not 16, not 25. I mean, 15 divides into it, but I don't know the square root of 15. 2 divides into it, but I don't know the square root of 2, right? So I can stop right here. Tell me what the square root of 4 is. 2. Tell me what the square root of 30 is. I don't know either, right? So this would simplify to be 5 plus or minus the square root, 2 square roots of 30 over 8. And that would be the answer, if that's what we got to. Okay? What if, however, I got all the way to right here and I did all my work correctly and my answer was actually 5 plus or minus the square root of negative 121 over 8. Dun, dun, dun. Do we know the square root of 121? 11. Do we know the square root of negative 1? I. So this would go to 5 plus or minus 11i over 8. Can I do right here what I did right here? I can't, can I? Because that would be combining real and imaginary. And the only place that works is where? Space Jam. Space Jam. Okay? One more what if. You ready for one more what if? Okay. What if it was, we did all our work and it was correct, and I got 6 plus or minus the root of 120 over 8. That's real close to this one right up here, right? So I know I could go one more step and say 6 plus or minus 2 root 30 over 8. But what do you notice about the two numbers in the numerator? This one and this one. They're both divisible by 2, aren't they? I'm not done then. I have to simplify my answer the whole way. So I could factor out a 2. And what am I left with if I factor out a 2? 3 plus or minus 1 root 30 over 8. Now, I'm super proud, first of all, that nobody said that that should be 15. Because you know, that I think, at least, I think you know that you can't take anything out of a root unless we're doing something like this, right? I know 30 is divisible by 2. You know 30 is divisible by 2. But you can't divide the 2 out of that term because the 30 is inside. It's protected inside that radical. Fair enough? So good job on that. But am I done yet? I got one more step, don't I? What's my one more step? Aren't 2 and 8 both divisible by 2? 3 plus or minus root 30 over 4. And that is the final answer. So you got to be ready for some different possibilities when you get to the end, right? You could get here where we got a number that we knew the square root of. Take the square root of it, do the math. Get 2 answers, 2 real answers that you knew were coming. Okay? You could get something under the radical that you don't know the square root of it. Simplify it if you can. You could get something under the radical that's negative. Well, you got an imaginary number going on there. Or you could get something where you actually have to factor out common terms all the way through. Yes, ma'am.
Okay, so we're only, like, we're not going to name the, these 2 imaginary.
So that's just if you're finding the discriminant. If you're just finding the discriminant, if it only asks for the discriminant, my answer is 2 real solutions because I got a positive number. If it's asking you to solve, we're not going to find the discriminant. We're going to find the answers, the actual solutions. Does that help? Are you lying?
No.
Okay, good. Okay. Any more questions? If you do have questions, what are you going to do? Ask me during class, tutorials, before or after. Any questions? We're good?